The label GMO comes with so much negative connotation that people regularly forget what it even means. No, they don't cause cancer, they aren't poison, and they definitely don't encompass anything and everything that we think of as unnatural. GMOs are simply any organism that has been engineered by inserting a different gene into it in order to improve yield, taste, nutritional value, or pest resistance, among other things. Originally created in the 1970s, GMOs have been the subject of copious debate in both public and scientific settings. But many of the naysayers out there lack knowledge of how GMOs really come about. In its most basic level, GMO creation involves 4 steps: identification, isolation, insertion, and cultivation. The identification step is the real vision step in the creation process. The part where scientists ask themselves, what do we want to make? This comes with answering the question of what are we trying to solve? If you're trying to make a crop resistant to pests, you're going to look at crops that are already resistant to pests to identify what gene could be used in the new GMO. Scientists creating golden rice, a crop that aims to stop vitamin A deficiency in impoverished regions, look towards vitamin A-rich crops such as carrots, lettuce, cantaloupes, and broccoli that could source the pathway that could be spliced into rice grains. After scientists have identified what organism and what trait they want to use, they have to figure out exactly what gene leads to it. Scientists first compare plants of similar genomes that have or don't have the particular trait to see what exact gene they're looking for. If this doesn't work, scientists can delete parts of the genome until that trait no longer exists in the organism to identify where that gene is. This deletion process was used in the Golden Rice Project, which ultimately identified the genes that allow for beta-carotene to be synthesized. The insertion step is essentially the copy-paste stage of GMO creation, but it's not nearly as simple as Ctrl-C, Ctrl-V. There are a few different ways to insert DNA once you have it. Metal particles covered in DNA can be literally shot into a plant seed using a .22 caliber charge. Alternatively, a specific type of bacteria, Agrobacterium, can be used to infiltrate a plant genome and transfer new DNA into the host cells, kind of acting like a natural genetic engineer. One other technique is using enzymes to cut and paste DNA into a plasmid that's then inserted into bacteria, which then can be introduced into a plant genome. Side note, I've done that one before and it's very cool.
It's green, we did it.
Next, it's time to put this new plant to the test. Scientists must grow the crop to see if all their hard work has paid off. If the new trait is not present in the crop, or if the engineering has otherwise altered the phenotype, it's back to the drawing board. But if the crop grows successfully with the new trait present, then it has been a success. And after that, it's up to the scientists to continue to cultivate and breed this new genetically modified organism. This whole process takes several years from start to finish, and it really makes you wonder, is all this effort even worth it? At the end of the day, GMOs aren't the evil, unnatural thing that many people think they are. They're feeding the future and solving problems in a safe way that proves just how useful modern science on a whole can be to solve the problems of this world.